All right, thanks everybody. Oh, let me see here, I'll plug my mic in. Thank you everybody for coming. A very gratifying turnout for sure. I think it's, for a lot of us, this is something that's sort of very in front of our faces, and feels like a lot to learn. Things have been changing quickly, and so hopefully we can sort of do this, and maybe other people will sort of run tutorials in areas where they're much more of an expert than I am. So Lex and I are doing this together. We've worked before teaching the coding and stats course, and so I thought it'd be really fun for us to do this together. I have quite a lot I want to say, so I'm monopolizing most of the time, but I'm making sure that Lex is carrying some load that I wouldn't carry as well. So we're going to have a lot of us are using AI, of course, for many aspects of our work. Probably, I would guess, although who knows, for most people, things like literature research and writing, documents is probably maybe the most common thing that people use it for. Lots of you also know that it's good at writing code these days, and we want to really sort of focus on that latter skill. And there's a strong reason for that. One is simply there are many topics you could cover, and you want to have some focus. But one of the other things that I think is worth pointing out is that writing code is in a bit of a unique category, and that is the following. When you ask AI to write a document for you, it's up to you to sort of do the manual labor of vetting what you think about that document, and you might suggest changes to it, you might do hand edits to what it produced, but it's not necessarily a very sort of fast process or very automated process, and there is no sort of ground truth really for what a good document is, right? That's a very subjective decision. And so coding is actually a little different than that. And the reason why is that there is essentially a ground truth, and that is if it writes code in a given programming language, that code is supposed to run, right? And so that provides a very strong yes or no signal to the agent for it to know whether it's done a good job or a bad job. That's not actually sufficient to know that it's done a good job, but at least it gets a very clear bad job signal when it tries to run its own code and it throws an error, right? And so what that implies is that coding is in part something that you can turn over to AIs and have them work on it for an extended period of time, getting feedback, learning from its own mistakes, and delivering something that's ready for you to probe more thoroughly. And so that's the main thing that we want to explore today. It's sort of the idea is, and I do this quite frequently, I'll get it launched on some task, and then I'll tab away and start answering my email or have a conversation with somebody, and I come back half an hour later and there's a working, at least nominally working code tree waiting for me when I come back, right? And so it's that fact that so much can be done for you behind the scenes that makes this a very sort of special category. And so we're going to run a couple of demos that illustrate some of those ideas. Those are going to be very brief, and then I'll be talking about some of the sort of more complicated factors that surround this. So Lex, you want to take it away?
Sure. Let's see. So I thought I would do one short demo. Obviously we're not going to stay here and wait 30 minutes while this runs, but to kind of give an idea of how agents can help and how agentic coding is a little different than if you've been running things in ChatGPT, getting a snippet of code, copying it into your code, doing a little more work, going back there, finding out another clue, copying that back. And I think that's usually where most of us met coding with AI. But there's a lot of inefficiencies there and a lot of room for error or problems to come up. One of the themes that Tim brought up, and he'll have a lot more didactic sort of thoughts on this, is that the code is the product. So that's what we and the AIs, we're trying to produce the code. We're not trying to produce the figure, the pretty thing at the end. We're trying to produce the code. And I think, in my experience, the AIs have been really game-changing and really helpful at that being the product. So I'm going to take you on one example. This is a data set from JAX. This is body weights of outbred mice, an outbred strain of mice. They have many strains, but I like this. It's quite a lot. somewhere between 60 and 200 mice at each body weight. And this is some of the type of data that my lab would do. So I'm going to use, in this case, we're using Google Colab. If people like programming in a Jupyter Notebook environment, this is just Google's version of the Jupyter Notebook. And of course, because it's Google, this is Gemini, but I think we're trying to be agnostic here, and just sort of the same concepts are there in whatever you're programming in and whatever sort of company is running it. So if I were to kind of get a data set or generate a data set and want to go at it, we could start with something that's like, I have data in CSV format. Can you give me This is Tim's waiting for 30 minutes if you ask it something more substantial.
Yeah.
But Gemini will come back with something. And what's nice is as this works, you are generating the code. If you aren't used to looking at code, that's kind of okay, as long as, for the beginning. And I also find that you can often, I've already downloaded this data, so I'm going to grab the 3-week data right here. It's kind of okay if you're not used to looking at code, but it also, I find it very informative. Sometimes you see, oh, it's doing things pretty cleanly. So now I've got this data. You can see that it's in this notebook. We could say I'd like a graph. I already kind of have looked through this data. We have some things like the sex of mice. We have value, which is body weights. We have some other things that are stock number and things that maybe we're not so interested in. I like a graph to show and then again, more info is usually helpful. I'd like a bar graph to show. Does that even? So it made a nice little plotting thing. That's telling me that male mice have a higher value than the female mice. Again, back to this theme that Tim will come to. What we've got here now is something that I could save, I can share, I can come back to it. It's very different than interacting with the chatbot and then scrolling all the way back to where you liked what it was doing and trying to kind of either get back there or put together your code again. I won't really belabor the point, but things that are, can I run a t-test on this? So here we go. Male mice are in fact heavier than female mice. And then the last sort of example thing is, and where this becomes useful, and what Tim alluded to is, let's say I have a lot more data. So on this JAX site, they have the whole growth curves of these mice up to 22 weeks. You might kind of pilot something on one image and really get your workflow nailed down on an image, but then you have 1,000 images that you plan to kind of crunch through. I have more. At other time points. And I'm not really even giving it, it could interpret that many ways of what it wants me to do. It's probably going to do a decent job of doing something reasonable. So now we've got a different version of that first one. I'm clicking accept and run on these. So if I go and grab from 3 weeks to 22 weeks, that's the Colab bringing them all in. This is what Tim brought up. So this code didn't run, so it made an upload that it failed. So objectively, that was not great code. It picked up on that. If anyone was sort of noticing that, it noticed the output was an error. It realized it was missing this import down here, and we're going to see if that fixed it. But hopefully this little example is kind of at least the flavor of how it, scaled up to more complicated problems. And is this one going to have an error? OK, and it did something reasonable. It figured out that I'd probably want a line plot of males versus females, and you can see them going over time. So the last, hopefully that was interesting or educational. The last point I would make about all this, and I think Tim will have more to say about this, is when we're done here, this is in my Google Drive. I could give it a thing, and say, like, come back to this later, waits later. I could also share it with people. But the agent has made a useful chunk of code that we could really work with and I could build off of and kind of come back to and importantly share with other people and say, here's my data set, I got it from Jax, here's my notebook. If you want to get this graph out here and see males and female mice, you have everything you need. So that was my short demo.
Very cool. Thank you, Lex.
Do you ever feel like you should check it?
Yeah, that is a great question. Do I feel like I should check it? Absolutely. So I didn't. Absolutely, I think it's critical that you have some understanding of what you should be seeing. Let's say this number came back with a 500 here, and I had no idea of how much mice weigh. That's going to be an obvious error that will propagate through. So having some concept of what your answer might be, having some ways to check it, and I think that's what Tim is going to talk a lot about, structured ways of doing that, having some ways to kind of go back from your answer and not just say the graph looks pretty, we're done, but how might you pick up if it's made some, I don't even want to say an error, what if there's another column, I wanted weights, but it's plotting months or something, and I haven't figured that out.
All right, do you want to swap out your laptop?
Yep.
Yeah. All right. Can I give this to you just to?
Yep.
Use the. All right. So So there are many ways you can do the agentic coding operationally. The way I do it is I have installed a command line application on my own laptop. I'll show you the demo before I switch over to the PowerPoint. Okay. So let's see here. So BJ. Sorry, what do I need to do to get this?
Yeah, let's do Windows P.
Thank you.
And say duplicate.
Perfect. Yeah, you would think so. Here's the agent, exactly. Okay, good, all right. So, yeah, I mean, one of the lessons is going to be the human is still really important, by the way, just so everybody knows. Okay, all right. So very much emphasize this is intended to be corporate agnostic. Basically, I think there's really no wrong way to go in the modern world. I happen to use a tool called Claude Code. This is something that I've installed on my own machine. It's a little command line program. You may have briefly seen a charming little 8-bit. It is here. Yeah, exactly. A little 8-bit icon. You may start seeing that a lot on people's computers as you walk around the building, basically. And actually I want to do one thing real quick to just sort of make sure that this is showing you something that you would be more likely to get started with, basically. So okay. So this is the medium through which I typically interact with agents, and this little caret here is the prompt for what I type. There are all these little helpful hints, talk about shortcuts and things like that. I'll point out a couple of things here. You notice it says Sonnet 4.6. That's the model. You all know, I think, at this point probably that there are different AI models out there. Opus is the sort of smartest but also most expensive one, and that's a very relevant topic. I'll cover that a little bit. Medium effort also means essentially how hard I'm having it think. And so it's kind of useful to sort of pay attention to some of those kinds of things. I have a pre-prepared prompt. I'll just hit the up arrow here. And it's very similar to what Lex has. I have a couple of CSV files on this. I'm imagining that you have some code that you've written on your, that analyzes your data, and it works on some files but doesn't work on others, right? It throws some kind of error when you feed in certain input files, and it doesn't throw an error on other input files. And so I'm going to ask it to try to figure out what is going wrong. And so what it's going to do is that it's going to run these scripts. And you can see here these quick little commands here. It's trying to run these things. You can see it's going to ask me for approval. This is a standard thing when you're working with agents. You can control what they're allowed to do and what they're not allowed to do. And this can be, quite important. And so I'm going to give it the approval to run these kinds of things. And it's going to run the second. So the first time it sort of printed out, you can see the very beginning, you can see it truncated some of the output here. And then on the second file that it tried to run, indeed, it reproduced the error that I had gotten manually. You can see that it's analyzing what kind of error it is, where it is. It's looking at the files. It's diagnosing the cause of that error. And it's already coming up with a fix, basically, okay? And if you read code, you can see, what the nature of it is. But if you don't read code, you can, this is a fairly interpretable thing. It turns out the last trial in this data, I asked for a 2-second analysis window, and the last trial happened less than 2 seconds before the end of the file. So it threw an error when it tried to grab two seconds worth of data starting from the last trial, right? And so it's going to propose this edit. Again, I would have to sort of approve that edit if I wanted it, wanted to do so. And then, it would, if I saved it, it would try to rerun the code and verify that the fix worked. Okay. So this is the kind of thing that goes on. And this I've deliberately set this up as this is a little like 10-line piece of code or something like that. But this works brilliantly well on really complicated code bases as well. And this is now the main way that I debug code. So I'm going to share a couple of basically stories with you today, and then mostly sort of go over some of the challenges. Let me just give you a sense for the fact that this is more than just a toy for simple little demos. So I'm going to give you sort of 3 success stories. And so one is that I've been doing a lot of data analysis. My lab studies olfaction. We're therefore interested in the receptors that detect the chemicals. We want to sort of try to start making sense of how receptor structure is related to the structure of the chemicals that they detect. And so we're working on ways to sort of put them into common frameworks and combine many different sources of data into one thing. It's a little bit like combining connectomic data with functional data of neural recordings, except in this case it's sort of structural biology data and the actual physiological responses of sensory neurons. And it's a fairly big machine learning challenge to sort of figure out how you weave these separate sources of data together. I'd done a lot of foundational work, so a lot of the pieces were in place, but I still felt that like the last bit of one component of this long ongoing project would take me something like a month or so to write. And this was, when I decided to tackle this, I had adopted agentic coding, and much to my surprise, I actually got the whole sort of thing woven together in about a day and a half, and I was very happy with the outcome that produced, right? So that was a really nice win early on. We have another example on a very different kind of data. My lab is putting together a new suite for calcium imaging that has some capabilities that the existing ones don't have. We're hoping to position this as a competitor to things like Suite 2P and Cayman. But our code, like those examples, it doesn't always do the right thing. And one of the ways in which I want to make it better is, or the way I figure that one needs to make it better is to understand why does it sometimes make bad decisions. And it's a very complicated thing because these are sort of long histories of decision making that it does, and you have to pinpoint the exact moment in the history where some bad decision happened, right? And so I had put some work into that manually several years ago. I had a couple people in my lab try to tackle that question, and I think collectively we put about 6 months of work into trying to really do this. And I would have to say, honestly, we didn't get that much out of that 6 months worth of work. We had some ideas, and I think that actually helped set the stage for later success, but nothing really concrete and deliverable came out of that. And I took a crack at this recently again with agentic help and came up with really concrete improvements in about 4.5 days using the agentic coding. So it was, again, a big acceleration. Probably the way in which it's been most useful, though, is a much more boring one, and that is that we have a lot of code that the lab depends on, and maintaining that code is always a sort of thankless exercise, basically. And so over the years, there have been all kinds of ways in which it hadn't been well documented. We knew we needed to redesign certain internals, but that was sort of a huge thing to bite off, and there was always something more fun to do in the short term and all this kind of stuff. And what we've been finding is that these agents are really terrific at just sort of solving your tech debt for you, basically. You can't do it all in one go. It's a very involved, structured process. So, but for code bases that took about a year's worth of almost full time, a year's worth of effort to put together, we're finding it can be refreshed in a week. A week is still a lot of time, right? We're putting real work into doing this kind of thing. But it's a task that none of us have been brave enough to undertake over the last decade or so, basically, right? And now all of a sudden it feels like so totally worthwhile, and new students who come into my lab can now learn from actually polished documentation instead of having to hear about things with the dusty cigar smoke of coming into my office and all, right? So there are I really do think that this is a genuinely game-changing technology for those of you who, like me, depend upon coding, to get science done. That said, it isn't all, a bed of roses, right? And there are genuine threats. And a big part of what I want to talk about today is how do you mitigate some of those threats and the ways in which you could maybe send your lab's code base off into a bad spiral, basically. And so there are really, there are many ways in which having this power is great, but having this power is also sort of terrifying, right? What I emphasize that the agents can run the code, and if it throws an error, they know they did a bad job. But if it doesn't throw an error, that doesn't mean it's right? And so if it looks like it's working, but it's producing wrong results, that's sort of a terrifying thing as a careful scientist to think about. One of the other things is the sheer rate at which you can produce code is also quite impressive. And even if you're good at coding and can review the code it produces, keeping up with, I like to say they produce reams of B+ code at insane speeds, right? And just keeping up with it can be really sort of daunting, right? And so it was often very happy to rewrite things that you had sort of working before, but there was just one bug and you asked it to fix that. And if you aren't careful about how you set things up in the course of fixing one bug, it might reintroduce one you fixed a few years ago, but it didn't realize that line of code you put in was really important for something, right? That's a kind of a scary thing. The agents can do a lot behind the scenes. You can ask them to say, oh, find the variable in my data set that correlates best with X, right? And it will just spit out a text answer to that question for you. But if you don't end up materializing that in code and you shut down the session, then that little nugget of information is lost, right? So this is this issue of remembering that the code is the main product, okay? And so fortunately, there are real things that you can do to protect yourself. And they're actually well known in the professional sort of code development community. But at least my experience is that scientists have not sort of always known about these tools and skills and just habits that sort of professional developers have been using for decades at this point. And so this overall sort of suite of best practices is sometimes called DevOps, for development operations. And it's got many sort of legs to it, but I'm going to tell you about two that I think are the most important ones, and really that I don't think you should sort of start turning your code over to agent attention until you've sort of taken these steps to protect yourself. And so the first one is exactly as Lex said, to remember that the most important product is the code, not the figures that code can produce. And one of the obvious reasons is you can go forward from the code to the figure, but you can't go backwards from the figure to the code. Another reason, though, that's really important is that code, being text, is very easily trackable. And so there is this concept called version control. It's sort of a vastly better version than what we often do when we pass Microsoft Word documents back and forth, and my version 7, now your version 8, now my version 9, now your version 10. There are much sort of better and more powerful ways of sort of snapshotting it. It gives you can use it to get essentially a running log of every change that happened. That lets you do forensic on what introduced a bad change if that happens, and agents will do that on occasion. So that's really important. So you can go backwards there. And version control is often in these days synonymous for Git and GitHub. So if you either are already using these, you can check that box. Congratulations. If you're not, it's definitely something that is at this point worth adopting if you are thinking of starting to use coding agents. The other one that I think is even less widespread in the scientific community than this, and this are the techniques in order to sort of become relatively safe in turning your code over to agents. So I mean, I couldn't emphasize enough how much it is, if you start adopting agents, you're undertaking what is potentially a dangerous exercise for your reputation as a scientist in producing results that are trustworthy, right? And so I think it's absolutely, before anyone does anything dangerous, you first should invest in your safety. And if you're on the trapeze, that involves basically building a net underneath you. And I think if you're working with agents to do coding, first thing you should do is build yourself a safety net. And the way that you build your safety net is what are called automatable tests, right? So testing. This is actually not very foreign, I'm sure, to many of you, even if you don't use formal testing, right? So one of the things that I did before I learned these skills, I was a MATLAB programmer at that point, and I would spend hours or days sometimes in the MATLAB debugger, going one line at a time, watching how all the variables were updated as I stepped through my code, right? And that's great in many ways. I mean, I had a really strong view and an understanding of how things changed in my code. But I found that I would get to, on some of my most complicated projects, if someone reported 3 weeks later a bug in the code, that was it was a scary thing to fix it. And there were, in fact, a few pieces of code in my lab that I had to tell everybody I was never going to touch it again, because every time I tried to fix one bug, I introduced a different one. And I never have to tell anybody that anymore. And the reason why is that I take all that manual labor that I used to put into watching how my variables update, and I write a whole different set of code which is devoted solely to testing, right? And what this basically does is it takes what you would do to inspect, yes, that's the sensible answer given the inputs that I fed in, and you automate it. You write code that executes the code you want to test, this normalize function, and then asserts that it gives you the correct answer. Now, you can't test on everything, right? Your actual biological data is probably pretty hard to use in testing. But if you create fake data sets where you control what the answer is, and therefore you know what your code should spit back at you, that's the thing that you can test, okay? And so what this does is this captures all that hard manual labor that's kind of a one-off. You can do one time realistically when you're first developing the code, right? And then it's a pain in the neck to ever do it again, right? And you turn it into something that you can run, this hour and the next hour and the hour after that. Every time you make a substantive change to your code, you rerun the tests, you see if all the tests fail or if they all passed, right? And if they pass, then you know that if you've written a good test suite, that you haven't broken anything that you were counting on. Okay, so that's the fact that it's repeatable is really important. And with agents, this is really essential, because essentially what tests become is the contract that you insist the agents must satisfy, right? You're not going to type into your prompt, make sure my code doesn't throw an error on file 37, or anything like that every single time you go to modify your code, right? The tests become the contract, the behavioral, your statement of expectations about how this code is supposed to behave. And I can't tell you how many times I've turned agents loose on my code base, and they make the changes that I request, and then they run the tests and 5 things fail, and so then they go back and they fix up their code again, and by the end I have a working product. So I typically create about as many lines of tests as there is code in my package, as a rough guide basically. So this is a serious investment. This is not just a couple lines of, does smoke come out of my code when I run it, right? This is a serious investment, to see if it's producing scientifically correct answers, right? But that is the safety net that gives you the freedom to rewrite without fear, to improve the algorithms, to add parallelization and make it faster, to fix obscure bugs, knowing that you won't cause bugs in much more important pipelines, basically, right? And so that is really, one of the most important things if you're going to be using agents to do coding. And once you've taken these steps, then you can automate a lot of the grunt work of coding. If you don't have a test suite in your lab, one of the very first things, probably the first thing you should do, ask the agent is, can you inspect my code, try to infer what I want it to do, and write a set of tests that enforce the existing behavior? Right? You're likely to get a mix out of that. The best time to write a test is when the intent is fresh in your mind and the agent's, because then they know what behavior you actually want. Very often, if you take a code base that hasn't had tests and try to add them retrospectively, you end up essentially baking in all the things it does correctly and all the hidden bugs that you didn't know about that it was doing wrong before, right? But if you can read code a little bit, often tests are actually easier to read than the implementation itself. You can edit those, take out the ones that you don't want, and those become the next prompt to, I noticed that, it produces this output given this input. That's not something I wanted. Can you fix it, right? So you can use the process of having it build that safety net as not only an investment in the future of that code base, but also the beginning of a polishing phase where your code gets better than it's ever been before, right? You can use it to fix bugs, and I use it all the time for that. Use it to add and improve your documentation. Change designs that you regret, right, but are just sometimes kind of too painful to face unassisted. So I don't know how many of you have writing code that depends on code that other people write. How many of you have done that and have had, say, the person whose code you're depending on release a new version of their package, and it turns out that your code is not compatible with the new version of that? Anybody? Has that happened to people before? Yeah, a good number of people, right? Agents are wicked good at figuring out how you need to change your code to follow a change in an upstream dependency of yours, right? So they could, and that's a very unrewarding task most of the time, basically, right? We live in a world of very freely available data now. Many of us don't really look at publicly available data sets that much because it's a pain in the neck, especially in the genomic data sets. That community has really figured out a set of standards, so it's pretty easy to get genomic data from a database. It's much harder to do that if it involves mice licking left or right, or all the different forms of sort of drug treatment that a patient could undergo, or whatever, right? But again, the agents are really good at inspecting the data and figuring out what things mean what, and then giving you a summary of that, checking their decisions, and then importing whatever weird format the authors of the publicly available data use to store their data, and getting it into a format that can run on your code, right? They're really good at that. So it's very freeing to start using more data than you've been able to get access to before. If you're a method developer like me, you can use it to, I often would make these really lovely methods and then never publish them because it was such a pain in the neck to go find 7 other competing methods, figure out how to run them, get a set of benchmark data sets to try them all on, summarize the results, all this kind of stuff. Now I just have the agents figure out how to download and compile and run everybody else's code, and then the fun part is right there waiting for me, basically, at that point. Now they can also, of course, help you with some of the things that are more fun in coding, like adding new features and very much analyzing your data. So it's not limited to the drudgery, but I think the part I appreciate most about them is how much of the drudgery of coding these things take away, and they speed it up, quite considerably. Okay. So I think we're roughly on time here. What I want to do next is transition to another topic, not just what can they do and how do you protect yourself, but I think it's also important to spend a little bit of time talking about, so I've been doing the agentic coding pretty heavily for about the last 2 months now. And I have accumulated a number of observations about what they do well and what they do poorly and why. And I think that's a very useful thing to have. I mean, I serve on a lot of sort of, thesis committees and qualifying exams, and we very often ask our students to, do you understand, the tools that you're using in your experiments? We as scientists tend to think that if you know how your tools work, you can diagnose failures better. You can sometimes predict the outcome of an experiment based on your understanding that the actual tool isn't quite like it is in the cartoon that they drew. You might know about the failings of a tool, and that might be a good incentive for you to develop something better that then advances the entire field, right? There are a lot of advantages in knowing how your tools work. I do think that this agentic coding is such an important new development, a new tool for neuroscientists to use, that it actually does pay for people to invest some time in understanding how they work. And that gives you the power to understand why they sometimes produce really awful, results, basically, right? So I want to go over a few things, a few of the phenomena that affect how the performance of these coding agents. That basically ask, how do you then use that information to get the most out of your agent, especially as you start giving it more and more complicated tasks, right? So that's a timely reminder. I would have been 37 minutes late to my talk. Okay, so I want to do talk about sort of 5 sort of separate topics, right? One is something you'll hear quite a lot about if you start sort of geeking out on these agents, and that is about context windows. Slightly less commonly discussed, but equally important, is attention dilution. I'll talk a little bit about a very practical issue, which are the usage limits, that if you're buying a paid plan, what you'll face in terms of how much work you can get done in a given session. A little bit about the model choice, that's fairly brief, and then some of the tooling that you need. I think the first 2 are really the most important ones to understand, and that begins very much with the context window. So a lot of us, I very much had this model when I got started. When I would enter something in Claude Code and hit enter, I think I was kind of treating the agent like there was another person on the other end that was just waiting for my next prompt, right? And so it would read my message, and then it would respond, and then it would be waiting for me, and I'd type another message, and then it would read that new message and then respond. That's not how it works at all, right? Every time you send a query up to your provider's servers, you're probably talking to a different server with no memory of anything that happened in the conversation thus far, right? And so how does it have a coherent conversation? The way it does it is the so-called context window keeps a log of literally everything you've talked about in that session so far. So yes, you might type your first message and the agent responds, but now when you type your second message, it turns out that message gets bundled with your first message and the agent's response, because it doesn't know what it said before, right? And then your second message, and then its response. And then when you do this again, it goes all the way back to the beginning of the conversation, bundles the entire longer and longer thing up, and sends it to the server again, right? And so what this means is that as the session goes on, you accumulate all this context of the conversation, and the entire thing gets replayed up to that point each time you interact with the agent, right? Now that can only happen up to a certain fixed size, and that's when people say your context window, what they're often referring to is the numerical cap on how long this context window can be. So for some of you, this will be about 200,000 tokens. For others of you, it might be 1 million. A lot of it depends upon how much you're willing to spend, basically, right? Everything that the agent does is based on that text. So for example, when it's fixing a bug in your code, it's read your prompt about how to trigger the bug. It's got a record of the commands it issued to try running the code and see what happens. It sees the error message that was generated in your terminal, right? And then it may read your source code, and it's going to bundle all of that text. All that is just text. And it's very much the same way you would interact with your computer. You're going to read the code in your editor. You're going to look at the error message in your prompt. You know, you're going to have heard the verbal statement from the person in your lab who said this code has a bug in it. And then you're going to sort of digest all that information and try to sort of figure out what was going on, basically, right? So all of the research that it did, all of the reading of code, all of the seeing what the programming language spit out when it fed in certain inputs, just simply gets inserted into this context window, okay? So even if 200,000 tokens sounds like a lot to you, think again. You start filling that incredibly quickly, right? And so it turns out then that managing this context window is actually one of the most important things that you can do. So I'm going to tab away from this for a second and show you. I'm going to deny this. And so one of the nice things you can do, for example, is you can actually, if you put this little slash in front of your line here, that means I want to execute a command, and I'm going to type context, and if you enter that, you can see it will spit out this, you know, cute little 8-bit graphic, you know, bar chart, basically, where all these empty boxes are context window I haven't filled up yet, right? And all of these are the things that are occupying it. So you can see how big it is. I'm already at 30,000 tokens, and I've hardly done anything out of a maximum of 200,000 tokens. So my context window is already about 15% filled. You can see what is it that's filling it. And it turns out I always start every Claude session with a certain amount of generic instructions, and I'll talk about that a little bit later on. So that's what's accounting for a good number of the sort of early tokens here, and then the messages, this purple. And this is the thing that usually grows to fill most of the window, right? This is how you know sort of how far you are. So I still have plenty of room left. I can get more work done in this session, but it gets towards the end. Now, one of the things that you should know is that as the agents get towards the end of the session, if they are more likely to do something called compaction, right? And they compact your context window. And what this is basically doing is they're saying, I'm about to run out of room for conversations. I need to save some space. And so what they do is they do a very sensible and very good thing in many ways. They look over your previous conversation history and they try to pull out the real nuggets, right? They don't necessarily need to see an error from having chosen the wrong tool to use on one line if they then followed that up with the correct thing that gave a useful and informative answer, right? So they're going to snip out some of the more useless parts of the conversation history, and they're going to generate a more compact version of the conversation. So that's a useful thing. It's good that they do that. I would urge you, having learned this the hard way, as you get started with agentic coding, anytime you see it compacting your context window, you should personally treat that as a failure on your part in managing the session. It means the session got too big for the agent to handle well. You didn't scope the task appropriately, and next time try to scope things better. And I say that simply because I think you'll learn most quickly that way. There are valid times to have a long conversation. It's actually okay if it compacts it. But keep in mind that anytime it's compacting it, it's going to throw away information in a way that you're not necessarily fully in charge of. And it might be sort of booting out some things that you were kind of counting on it to remember about the earlier conversation. So I think is a good thing that I learned, you know, sort of slowly was to really treat compaction as your problem and not the agent's problem, basically. Okay, so going back to this. Okay, so right. So it turns out that it's very tempting to say, okay, if my context window isn't full, everything is fine. You know, it's only half full, so I don't need to worry at all. And that is in many ways true. But you should also be aware that the quality of the agent's reasoning is not uniform across the different areas of what's in the context window or as it gets bigger, right? So this is a relatively early analysis that's not maybe entirely true anymore, but there's definitely an element of truth to this. I've seen this happen. So this is a measure of the accuracy of an agent on a task as a function of where information is in your conversation history, effectively. So information that appeared very early on in your conversation, the agents tend to be really good about remembering that and getting that right, right? As time goes on, they get worse and worse about that. And there's a bit of a boost. They're a little bit better at the very recent information, right? And so this actually really should be something that you think about as you structure a session. So especially early on, I found it took me a while to figure out that this was what was going on here. I might start out a session with one set of ideas about how I think something should be designed, and we start making progress in that direction. And then I see, well, certain things I didn't anticipate are happening when it tries to analyze my data. Maybe I want to change my guidance a little bit. And so what can happen is a statement or two after, the interaction or two after you've issued that, say, oh, I think I want to change my priorities on this, right? It's still in the very recent history, and the agent pays a lot of attention to it. So it looks like it's learned what you said. Oh, I'm changing my mind. And you think, okay, it's going with that, right? But you wait a little longer, it gets a little further back in history, and all of a sudden, your initial instructions actually get more weight to them than your correction midway through the conversation. And you start noticing then that the agent gives you this almost random, unpredictable mix of things that were aimed towards your original goal and things that were aimed towards your revised goal. It's a complete and utter mess in that state. And the best thing you can possibly do is shut the session down instantly and start fresh, right? No point in going forward under those circumstances. You can end up with really borked code if you do that, okay? So like I said, I think this is very outdated, but there's clear evidence that the larger your context window is, the worse the performance. And this is, this is I think from December of 2025. And you can see on some fairly difficult tasks, even as the context window grows to very modest sizes on what's possible with modern agents, the performance does start to degrade. So it really matters how you instruct the agents at the very beginning, because that's the part that's going to do best on. Okay? So these two observations, that context windows fill up quickly and that they're limited, and that the quality of the agent's work is very strongly dependent upon the size of the context window, has a really important implication in how the agents have learned to be strategic about it. And that is that they basically look at the world like this. Okay? So you interact with an agent and they seem to know everything, right? But that's, and of course that's not true, but they know a heck of a lot more than I do about a lot of topics I know nothing about, right? So their breadth of knowledge is stupendous, right? But keep in mind that that is what got built in during the very hundreds of millions of dollars process of training the initial model, right? Now you're asking it to work on your specific code base, something it's never seen before, right? This is not wired in to the synaptic strengths of that model, right? This is something that it has to learn by looking at your code. And the agents basically have been trained to know that what they should do is they should get as much done by reading as little of your code as they think they can get away with, right? And so you may have a package that depends on, say, 10 source files. It may only read 3 of them, right? And then it's going to make guesses based on how you've named your functions, what the names of the variables are, anything that it might have noticed in the README. They use all these tricks to make inferences about how your code probably behaves without actually ever reading how your code works. And so I've had long conversations with agents where they say, oh, the reason that your model isn't working is because the L1 regularization in it is, causing this. And I say, what L1 regularization? You idiot. Read my code. There is no L1 regularization in my model. And they just guessed that there was, right? And so you should be very cognizant of the fact that they're going to read as little of your code as they think they can get away with. And you sometimes have to explicitly instruct them which things they should be reading in order to get good performance. Okay, let me cover another thing, usage limits really quickly. The way at least I haven't used Codex, so I don't know, but I imagine it's somewhat similar. They throttle you in both 5-hour session chunks and week-long chunks, and how much they let you use depends basically on how much you pay. If you sign up for the Pro plan on Claude, at least, I found at least that I would often hit my limit within a couple hours of working on it, and so that means basically you have to stop doing whatever it was you were planning to do with the agent until the next 5-hour block of time. The agentic coding is quite expensive compared to if you're using it for just chatting and writing documents and all that kind of stuff. It's much more expensive. And so at some point you sort of start trying to psych out what this is going to cost you. And one thing that I would caution you about being too worked up about is how complicated you think the task is. That does predict the agent investment, but relatively poorly. So this was a large set of tasks that had been classified by humans as how long the human thought the agent would need to work on it, and the question is whether that prediction A was true in and of itself, and B, would that predict how many tokens it used, which is the thing that measures your usage basically. And it's a pretty modest predictor. Only the most complicated tasks were reasonably reliable in predicting how many tokens it would take, and a lot of other tasks, the variance is much larger than the systematic mean there. So we're not that good at figuring out which tasks are going to be easy for the agents and which ones are going to be hard. So it's the things that you can control are some of these very almost mechanical things. So it's just predictable that the longer your session goes back and forth, the more and more expensive it's going to be to you. Nominally, it actually grows quadratically, but they have tricks that make it not quite that bad. The amount of text that it has to read is going to grow the cost of your conversation. And the number of times it revises the same document. Again, try to get it right the first time, because if it has to make update after update after update to the same function, it may be reading the entire file 5 times, and that's 5 times it appears in your context window. Real briefly, model choice matters. So which model you choose affects the accuracy. Higher accuracy can, of course, mean that it can compute a task sometimes right the first time. That saves you a lot of context. On the other hand, more powerful models tend to charge you more in usage. So the same number of tokens on Claude Opus costs you more than that number of tokens on Claude Sonnet. So keep in mind that's a significant factor. And you can control. I showed you on the command line interface, that you at least can see which model you're using, and you can switch dynamically. And eventually, you'll get to a point where you have a good guess of what kind of. Oftentimes, actually implementing a change that you've already agreed upon and planned out, that can do it on a pretty low tier model. That tends to be pretty straightforward. It's really the decision making where you want the most highly powered models generally. Final thing I'll just say, because time's running short, in order to have the best efficiency in working with this, you might need something called an MCP server. What this basically lets your agent do is launch your Python session or MATLAB session or Julia session or R session and keep it live in much the same way that you might open this up and interact with it over the course of a day or so. All the data that you needed were already loaded into the session. You may have generated some preliminary intermediate results, and the MCP agent essentially just lets it mimic the thing you would do, which is just enter the next interactive prompt on the line. And I'm not going to tell you how to install those, but you should just search for MCP server, and that will help get you going. Last thing I want to do is talk a little bit about a few tips that I've learned to become more effective. So now that you know more about the ways in which these agents can really be very limited in what they're able to do and how they're able to reason, then you can start designing workflows that matter a lot. And this matters enormously. I think I am 2 to 3 times more effective now that I have refined my workflows than I was when I first started. This is huge. It is more important for you to develop good workflows than it is to wait for the next model that comes out of the AI labs. That improvement in you will make more difference than the next shiny object that comes out of these companies, right? So the first thing to note is that these agents have different modes. I'll show you that really briefly. So I'm here in default mode. Say hi. And it's about to do something. Oh, shoot, thank you. Apologies. Okay, so this is the normal mode. If I hit Shift and Tab, you can see I'm now in this Accept Edits mode. You may notice that it was always prompting me for permission to read certain files or make modifications. That's a good thing. But at a certain point, you kind of have set the direction and you just want it to get the job done without bugging you so much. And so hitting Shift Tab puts it into a mode where it can get all these things done. A really important one is this Plan mode. In this case, it's not going to make any changes to your files. It's just going to come up with a plan, okay? And so and this is a great mode to put it in when you want it to do a lot of scouting around and researching, right? To see what does your code base look like and all this kind of stuff, okay? So, okay, and plan mode turns out to have some benefits that are not very obvious. The main reason why, again, comes back to these attention and context window issues. The only thing that survives when you exit plan mode is the plan. So all that stuff it spent reading through reams and reams of code or documentation or poking at data sets and figuring out how they were formatted, all that gets flushed. And the only thing that survives is the plan that you and the agent agreed upon. It's an incredibly effective tool, and you should absolutely use it. Another thing that I highly recommend is creating a file that describes essentially your values, what you care about, and how you like to work. So in Codex, this is an agents.md file. In Claude, it's claude.md. And so for example, mine says, is one of the very first lines, it basically says, I am a scientist, I don't like hidden bugs. When something seems wrong, I want you to write code that just throws an error as quickly as possible, right? As soon as you detect there's something not quite right, throw an error, right? Because that lets me see the error, and then I know something is wrong, and you can dig in and fix it. If it tries to make something up, oh, I'll just, this was a negative number. It doesn't make sense that it was a negative number. Well, I'll just truncate it to 0, right? No, right? Bad news. So have it throw an error at the sort of drop of a hat, and then you and the agent together can fix it, right? I also say, so you can actually set it up with permissions to read GitHub issues and submit pull requests and respond, read issues and try to fix them. And I do that because I have a lot of code to maintain. I have an instruction in my Claude file that says don't impersonate me on GitHub. Don't post a response to a user that you've written and not run past me, right? So all these things that you don't want it to do that you might learn the hard way, put these in your claude.md file and shut that behavior off for the future, right? Maybe the most important thing I can say is that your prompts matter. Hopefully you realize that even more. If you didn't already, it's even more important than you thought before, especially that initial prompt, right? You should treat your prompts the same way a programmer would treat code. I write them carefully. I commit them to version history. I try them out and see how they work. When they generate good results, that's great. But when they generate crap, I modify the prompts and I use them again. So I try to identify skills that I ask the agent to do over and over again. I have a lovingly crafted set of skills that are essentially little mini programs that actually cause Claude to do what I want Claude to do in the way that I want it to be done. Okay? This is the biggest game changer I have seen yet, is to customize your workflow and refine things iteratively through experience. And then the final thing that I have found that's very important is that I find that I am not matched well to how agents think about the world. When I think about science, I think about big things like get the figures for a paper together or aim 2 of my grant, right? And Claude does not work well on that scale at all, right? And so the thing that I've found is also very, very useful to do is to ask it to help you craft a plan that can be achieved. And so this is a little bit like that planning mode, except it's one I've actually created myself, and I'll give you a QR code in a second where I'm sharing that with you. And the idea basically is you take something like, here's my grant, read my grant, we're going to do aim 2 in this session, right? Aim 2 is an analysis aim or something like that, right? Way, way too big for any single session. But what you can do is feed that to a planner. A planner can create a stepwise chunked sequence of attack. And the key thing is that the state, meaning like where you are, is managed as a file on your computer. So it basically takes notes for itself as it goes. If those notes are concise and compact and accurate, it gets smarter as your work on AIM-2 unfolds over days, weeks, and months, because it knows more of what you know about the science, but it keeps everything manageable. And their goal is you get in, the chunks should be sized so that you get in, you get one deliverable, and you execute, you commit it, and you exit the session, right? And it does the handoff in much the same way that a medical team caring for a patient would do, when they go off shift and the next, team comes on. And that's very much the workflow that I find heals this divide between thinking big in science and the fact that the agents can only do very small focused things, basically. And so that's basically that. Okay, things to take home with you. So if you want, you can photograph this thing. This should work for both Codex and Claude if you want to do this. This is my personal configuration folder that has at least a dozen skills in it. Many of them are related to Julia package maintenance. They're probably not that useful to you, but a couple of the things that have new analysis in them are probably the things that might be most of interest to you. I also find that when I want to understand the exact method that an agent is taking to solve a problem, they're not always that descriptive. And so I have it, I have this little thing that basically like writes up a little methods section based on what it's been doing there. So those are the things that I found most repeatedly needed for doing science. And then a lot of the rest is code maintenance, and you should customize things to whatever programming language you work in for doing that. Okay, I will quit there. Hey. Also some learning resources. If you don't know much about GitHub or testing, some of these resources might potentially be useful for you. So wrap it up there. Sorry for running a couple minutes over, and Lex and I can both take questions. So. I should also say, I don't just mean questions. Anybody, and I know several audience members have extensive experience with agentic coding. If there's anything that I missed that you think is a really important lesson, I strongly encourage you to ask for a microphone and chime in with your comments. So, did I see a hand up? Yeah, Wayne.
Do they all have that /context command?
I'm not certain, but I think they do. Yeah. Yeah.
Thank you.
Sure.
Yeah, I had a question.
Oh, it's off.
Hello.
Yeah.
Hello. Might be off.
There.
Yeah, I had a quick question about compliance. I know that WashU, they limit certain code
Yes.
and agents. So
Yes.
yeah.
Yeah. So if you have sort of protected data, right? This is something I don't deal with, so I don't have personal experience with it. Zach, do you have insight into that? Yeah.
I could answer this somewhat if you
Yeah. Grab the mic, please. I would rather have you answer it than me. So yes.
Hello. Hi, I'm Dr. Zach Abrams. Tim was very nice to invite me here. I'm a faculty member in I2, and I do deal with sort of some of the compliance stuff. What I'm going to, we also do teach an AIQ course where we would go over more of this in detail. The very short answer to your question is the following. These companies would very much like to be able to train their models on your scientific data, even if it is not like patient data. Please do not provide any large companies with your data for free. Please do not do that. The majority, especially anything that is patient-facing or HIPAA, there are frozen set models. There is part of the Center for AI, Health AI, or CAHI, has a list on their website of approved models that you can use, which are, for example, HIPAA or FERPA secure models. These normally work, just so that you are aware, by not only being housed in protected environments, but also they are a frozen model. That simply means that any part of your conversation or the context that you put in cannot actually be accessed by the model. In other words, it doesn't change the weights of that model, so it cannot train or learn anything from either the mouse data that you've spent a lot of time and energy collecting or anything related to anything that's patient facing. Is that okay?
That sounds great. So, yeah. Others?
This is more of a comment than a question, but
Good.
I think one disclaimer, we want to emphasize is that, we should, emphasize is that, Tim knows exactly what he's doing in a way that most of us are not. And I mean, no, I'm really scared that, if,
Yeah.
especially, if you are trainee, by doing grant work, you learn a lot. So,
Yeah.
maybe, if
Yeah, so that's a good point, and I ran out of time to say this. One of the things, so Naoki is right. So this tends to be, the phrase often used is a force multiplier. If you have very good coding habits, it just makes you more effective. If you have very bad coding habits, it can send your entire code base into a death spiral, right? And so this is why you actually need to develop some of these, skills that the professional software development community has had for a long time, but that have not been widely adopted, is my experience at least, by the scientific community. One of the things that I'm so glad you brought this up, because A, the warning is useful, but the second thing I should point out is that these skills here, one of the things I worked really hard on was taking my decade or so worth of experience in how you do this reliably and tried my best to bake them in. Now that doesn't, I still drive the session, right? I'm still correcting the agent when it screws certain things up. And that's only because I know what I am doing, right? But these have improved its habits enormously in my experience by using these pre-packaged skills that I've edited and tried to sort of boil in, these habits. So that's one of the reasons why I wanted to share these with people, is that if you pay attention to what it's doing, and it will sometimes prompt you to do certain things, that's basically maybe it nudging you to do things that you should already be doing, basically. So you can, I strongly recommend starting all this on low stakes stuff that you don't intend to publish anytime soon, because you're gonna screw up in your early days. I did, and I've been doing this for a long time. But by using these tools, and I don't just mean these, but just by going through the process, you'll eventually learn what things are more safe to do and what things are less safe to do, and develop better habits, I think, right? So it's not, I agree that this is very risky terrain and you should be aware of that. But I have tried to essentially make these part get work done and part educational for that very reason. Okay, no more questions. Thank you all for sticking around, and happy to answer questions out in the lobby too if people have some.